Good morning, Year 4, and welcome to your next maths lesson. Okay, so today is Monday the 1st of February and our learning objective is to multiply and divide by 7, and this is the reasoning and problem solving lesson. So if you could just pause the video, write today's date and learning objective and underline these. Okay, so today we're thinking about how we can use our times table facts, our 7 times table facts, and apply these in problem solving scenarios, and becoming much more fluent with the 7 times tables. So let's review what we did from Friday last week, and I want you to create 2 calculations using the digit cards and symbols below. So we've got equals, 8, 4, 7, 56, and divide. So we're going to be dividing today to create 2 calculations. So pause the video and then have a go at this question. Write the inverse calculations as well to the ones you create, and if you need to use the number tracks at the bottom, there are the 7 times table to help you. Pause the video while you have a go. Okay, so we know we're going to be writing 2 division questions to start with, and when we divide, we start with the biggest number. So we're going to use 56 divided by something. So we know we're looking at our 7 times table. So let's do 56 divided by 7. And to work out how our answer, we can use the number tracks at the bottom to count how many 7s there are in 56. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 7s in 56. So 56 divided by 7 must equal 8. So the calculation you should have written is 56 divided by 7 equals 8. And if we know that 56 divided by 7 equals 8, then we also know that 56 divided by 8 would equal 7. So those are the 2 calculations you should have written. And then the inverse, so we know the inverse of division is multiplication. So we should have written 2 multiplication questions. So you should have written 8 times 7 equals 56, and 7 times 8 equals 56. So well done if you got those correct. Okay, so let's look at our first question here. So how can we solve this calculation? Complete the statement below. So we've got 63 divided by 7 equals something. So to help us, so we know that 63, another way of saying this question is 63 shared into 7 equal groups. So I've got 7 equal groups here on the screen, 1, 2, 3, 4, 5, 6, 7. So I could share 63 counters into these 7 equal groups. Now that's going to take quite a long time for me to share individual counters counting up to 63. So you may want to just count. We could use our knowledge of inverse and count how many 7s there are in 63 to work out the answer, or you could draw an array. So I'm going to let you pause the video while you work out what you think, how many 7s you think there are in 63, or 63 shared between 7 equal groups, and then we'll go through the answer. Okay, so just to help you see what this would look like visually, if I shared 63 counters into 7 equal groups, this is what the 7 equal groups would look like. So there will be 63 counters here altogether shared in 7 groups. And then if I count how many counters there are in each group, that will give me the answer. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 counters. So there are 9 counters in each group. So 63 divided by 7 equals 9. So that should have been your answer. So well done if you got that right. And I can actually count so here I wrote, what is the inverse calculation? So the inverse would be the multiplication. So it would be 9 times 7 equals 63. So 9 times 7 equals 63. Have counted in 7s to help me work out that answer. So I would have counted 7, 14, 21, 28, 35, 42, 49, 56, 63. So I counted 9 groups of 7 to get to my answer 63. Okay, so I've got two calculations here, and I've put what different ways can you solve these calculations. So I've looked at this question here, 4 times 7. So to solve 4 times 7, I could just count in sevens. So I could count 4 groups of 7s using my knowledge of my 7 times tables. Or if I want to show that using a visual representation, I could use an array here. So you can see I've drawn out 4 groups of 7, 1 group, 2 group, 3 groups, 4 groups, and then I could count how many counters I've got all together. Or I could use a bar model again to show my 4 groups of 7 at the bottom here, and then I can put in my answer there. So 4 groups of 7. So if I count in, you can count in sevens with me to work out the answer. So I've got 7, 14, 21, 28. So 4 groups of 7 equals 28. And I can put my answer in my calculation there, and I can put my answer onto my bar model. Okay, so using your knowledge of these different methods, can you have a go at answering 49 divided by 7? Now I know it's a division question here, but we can use the same methods as multiplication. So we can use our knowledge of inverse, so how many 7s there are in 49. So we can count in groups of 7 to find how many 7s in 49. We could work out our question using an array, so we could do 49 counters shared into 7 equal groups, so 7 rows, 49 share 49 counters into groups of 7. Or we can use a bar model. So pause the video while you have a go at answering this question and representing it in different ways. Okay, so here's what you might have come up with. So something times 7 equals 49. So I'm going to come back to answer that question in just a moment. So I could have used an array. So here I've got 7 rows, and when I share 49 into 7 equal rows, there are actually 7 in each group. So that means that 7 times 7, or 7 groups of 7, equal 49. And here's what the bar model might look like to show that. So we've got 7 equal groups of 7 here, and the answer is 49. So it's 49 divided by 7 equals Okay, so here is an example of a part-whole model, and you may see a part-whole model in one of the questions today in the steps. So let's go over how we might work out how to complete the part-whole model. So the whole number would be at the top of our part-whole, and these are the parts. So one part is 3 times 7, and the other part is 8 times 7. So that means that the whole number must be 3 times 7 and 8 times 7. So 3 groups of 7 and 8 groups of 7 means the whole number is going to be 11 groups of 7. So if I can find the answer to all 3 of these calculations, I would have a complete part-whole model. So I'm going to just count in 7s to help me work this out. You may want to pause the video and work it out a different way, or you can continue listening to me and we'll go through it together. So 3 groups of 7, so 3 times 7, if I count in 7, so 7, 14, 21, so 3 groups of 7 is equal to 21. 8 groups of 7, so I can count 8 7s, so 8 groups of 7 will be 7, 14, 21, 28, 35, 42, 49, 56. So 8 groups of 7 equal to 56. And then we know that the whole number would have been 11 groups of 7. So to work out 11 groups of 7, I can either add these two numbers together, or I could use my knowledge of 7 times tables. So I could do 10 times 7. So I know that 10 times 7 is 70. So therefore, I know that 11 times 7 is 77. And that would be 56 add 21. I know is also 77. So here now I've got my answers to my part-whole model. So my part-whole model, if I just put on the answers, would look a little bit like this. So 77 is the whole number. One part is 21, and the other part is 50. Then if you drew out your part whole model looking like that, and there's, you can see the answer there, so we know we're correct. Okay, so let's look at a problem solving question. So we have got, let's read the problem and work out the important information. So 1 apple costs 7 pence. How much would 5 apples cost? And then use a bar model to solve the problem. You can draw an array if it helps you. So the key information is we've got 7 pence there, and we want to know how much, if 1 apple costs 7 pence, how much would 5 apples cost? So the calculation we're working out would be 7 times 5. So 7 times 5 is the calculation that we are working out. So if you want to pause the video and have a go at answering that question by drawing an array or a bar model, and then you can use the stem sentence at the bottom here. 5 apples would cost, and I know this because. Okay, so let's go through how we might answer 7 times 5. So here you could see this is what an array might look like. So 7 groups of 5. So I can actually count in 5. So I know my 5s times table, so I can count in 5s to help me. So I've got 5, 10, 15, 20, 25, 30, 35 there. Or I could count in 7s the other way. So I've got 7, 14, 21, 28, 35. So 7 times 5, which is the same as 5 times 7, is 35. So that's the calculation. And if you drew a bar model, if you want to check your bar models, your bar model, you could have drawn it 2 different ways. You could have drawn either 7 groups of 5, and your answer would be the same as 35, or you may have drawn 5 groups of 7, which also equals 35. So you should have answered the question by saying something like 5 apples would cost 35p, so we're working in pence, or 35 pence. I know this because 7 times 5 equals 35, and you may have proved that by using an array or a bar model. Well done, year 4. Okay, so here's my next question to you. Which is the odd one out, and can you prove it? So I want you to look at all of these calculations and work out which one is the odd one out, and can you tell me why? Can you explain why using I know this because? So you've got 42 divided by 6 equals 7, 56 divided by 8 equals 7, 7 times 6 equals 42, 7 times 8 equals 56, and 48 divided by 7 equals 7. So I want you to pause the video now and see if you can work out which is the odd one out. Okay, so to help us do this, we can work through these one by one and see if we think they're correct or if we think they're incorrect. So 42 divided by 6 equals 7. So 42 is 6. I can use my knowledge of times tables to help me. So does 6 groups of 7 equal 42? Well, yes, they do. I know that 42 is a multiple of 7. It's in the 7 times tables. And if I count up 6 groups of 7, my answer is 42. So that one's correct. And actually here I can see that that calculation written slightly differently is the inverse. 7 times 6 equals 42, and that one's correct because also I know that 6 times 7 equals 42. So I'm going to put a tick next to those two. I don't think those are the odd ones out. And this one here, 56 divided by 8 equals 7. So I do know that 8 groups of 7 equal 56 because I've already practiced counting 8 groups of 7 right at the start of this lesson. So I know that that one is also correct. And here is the inverse of that question. So 7 times 8 equals 56, or 8 groups of 7 equals 56. So that one's correct. So here, my final question, 48 divided by 7 equals 7. Now that one, I'm going to put a big cross next to it, and it's wrong. And I wonder if you've noticed or could tell me why it's wrong. Okay, so it is wrong because 48 divided by 7 does not equal 7. 48 is not a multiple of 7. It is not in the 7 times table. So therefore, this is incorrect. What should it be? What is the closest multiple of 7 here? What is 7 times 7? It's not 48. It's actually 49. So that question is incorrect. So that is the odd one out. So you should have written something like 48 divided by 7 equals 7 is the odd one out. I know this because 48 is not a multiple of 7. It is not, as it is not in the 7 times table. So the calculation is incorrect. So that's something like you should have written there. So well done if you noticed that one. Okay, so here I've got a maze that I want you to travel through. You can only travel through the maze using multiples of 7, and you've got a start point here and a finish point. And if you want, you can write out the calculation for each square on your route. So the first one is 35. So 35 is my first square on my route. So I know that something times 7 equals 35. So I can use my knowledge of times tables here. So I know that 5 times 7 equals 35. So if you want to write out the calculations to help you, this would be a good place. So here's my first square, 35. Now I need to work out, am I going to go up, down, or across to work my way to the finish point? So 6 is not a multiple of 7, 32 is not a multiple of 7, 84 is a multiple of 7, okay, and I know this because 10 times 7 is 70, 2 times 7 is 14, and 70 and 14 added together is 84. So that means I have done 12 times 7 equals 84. So that's my next square on my maze. Now the next one's a little bit easier because if you look at my option 27, 52 or 70, so I think you can probably work out which the next multiple is of 7. So pause the video and see if you can finish traveling through the maze, writing out the calculations for each square you travel through, and then I'll show you the answers. Okay, so my next square would have been 10 times 7 equals 70. So this is my next square here. And then if I was looking at whether I go up or down. Now, 7 is a multiple of 7. However, I'm going to try and get to the finish point. So if I look at my other options, I've also got down here 49. And I know that 7 times 7 equals 49. So I'm going to take that option there and go down in the maze. Okay, so my maze is starting to look a bit like this. So I've got this was my next 2 squares, and then my next one again I think is an obvious one, so because I know that 10 times 7 is 70, and then my final square is 6 times 7 is 42. So that is the route that you should have written, and the calculations you should have written are 10 times 7 equals 70, and 6 times 7 was 62. Okay, well done. So checkpoint question. So I shared a box of cherries between 5 friends. Each friend has 7 cherries. How many cherries were in the box? So there's a visual representation here for you to help you. Can you solve that calculation and write down your answers? Pause the video while you have a go. Okay, so 5 groups of 7 is the calculation that I'm looking for. So 5 times 7, if I count 5 groups of 7, the answer is 35. So well done if you got the checkpoint question correct. If you did, you may move straight through onto step 2, or if you're still a little bit unsure, start on step 1 and have a go at that question first. So here is step 1 questions for today. You can show any working out you want to using counters, arrays, bar models. Step 2 questions today. Step 3 questions today. And if you want a challenge, here are the digging deeper questions. Move through the slides now to see the answers. Step 1 answers, step 2 answers. Some do have more than one answer, so have a look through. Step 3 answers. And finally, the digging deeper answers. Okay, well done, Year 4. I look forward to seeing your work that you produced today.